In this procedure, we will be calibrating the Omega TX206TH sensor transmitter head and the thermistor. First thing we want to do is hook up our USB programmer. Terminate your USB programmer to terminals 1 and 2. Open up your USB SpeedLink software. Make sure it says Omega. There are several versions out there. We use the version that Omega brands. Open up your custom config file or make it look like this. It's basically just picking the settings and make sure that the sensor you pick says 44007 and make sure your range is set to this, because we're going to truncate this range, and that way we'll get better resolution. Plus, the values I picked are come up with even resistor values for our resistor box, because we can't do 0.5, that would be a pain. So picked even resistor values. Connect this like this. You should be able to, if connected properly, you should be able to hit this button and pull current data. It may not be right. You should be able to pull some kind of data to the data box. Once you have the connection, you want to send the configuration, click this button. We will send the configuration file. Once it is done, you'll get a configuration successful box. One thing I would caution you about is this will load the circuit. So we are going to load our circuit. When you have your USB configurator hooked up, you will not display the correct data on the PLC or runtime HMI. Once you've programmed it, that is all we do. Disconnect it. You should only have to program it during installation, or if you find one that hasn't been programmed previously, which after the first round of calibrations, they should all be programmed. At this point, I have disconnected the thermistor and hooked up our decade resistor box. We are going to send our low signal, which for this calibration range is 16,330 ohms. To set the decade box, everything that is pushed up is not in the circuit. So when I pull something down, it puts it in. So I'm doing 16,330 ohms. So I'll pull down the 10K, the 2K, and the 4K. That adds up to 16,000. I need 330, so I'll pull down the 300 and the 30, and this will add 16,330 ohms of resistance between these 2 points. And that should simulate our low end of the scale, which is 32 degrees Fahrenheit. Once you've done that, come over to your runtime application. Your calibration app will see that currently my present value. Before we started this, we should let everything warm up. Make sure everything's on for 30 minutes and let all the electronics warm up before you do your calibrations. So we're floating about 4.005 and 6 milliamps. So just watch it for a little bit, and I don't know, we'll call that one. We'll put that in there. We'll change this value to 5. That will write directly to the PLC and set our low. Now we're going to go reconfigure our box for the high side. Make sure that the min and max here match, because if you're doing a new calibration, the values that we have been using are not correct. I'm not saying the calibration isn't off, but they played around with the numbers to get it close. It's not precise for our ISO calibrations. So we've picked 32 degrees Fahrenheit and 140 degrees Fahrenheit, so our resistance values come up with even numbers. Get your decade box. Now we're going to reconfigure for the high side. And if we look on our sheet, we'll see the high side of 144 degrees Fahrenheit equals 1244 ohms. I'm going to pull everything up to the top, clear it out. Notice the out in the end, so we need 1,240 and a 4. So that should inject the correct signal for this box in there. So let's check our calibration apps. And we should be close to 20 milliamps coming in. Our present raw value is 20.000, and so that looks to be dead nuts on. Our present scale value is 140 degrees. It's floating a little bit. That's normal. You're never going to get it exact. Now, I can check the validity or the linearity of this by simply taking one of these other values somewhere in the middle and just punching it in. So if I have a low end, let's just try 1801 and see what we get. We do 1801, we should get 122 degrees Fahrenheit. So I'm going to change my resistance value to 1801 on my decade box. There's 1,000. 400, 700, 800. I think I said 1 ohm, 1801. Yes. And so now we should be displaying 122 degrees Fahrenheit. And we're pretty precise. You're not going to ever get it exact. The decade box is calibrated. If you get within a tenth of a temperature mark, then we're doing well. Once you've done this, disconnect your decade resistor box, hook up your thermistor back up, and you should be reading ambient temperature right here once we have this in. So I'm going to pause the video here real quick and we'll hook it up and make sure we're reading ambient. So I've re-terminated my thermistor probe, and it's kind of cool in here today, so I'm reading ambient temperature of around 70 degrees, which is probably correct. I can verify that this sensor is working correctly by simply taking the probe and by rub on it or add a little friction. I should begin to see it warm up. Might take a little bit, but you'll see that temperature go up just to verify that it is transitioning. Yeah, so when I was touching it, it kind of threw off the resistance, but after I let go and put it on the table, now it's showing 81 degrees, brought up about 10 degrees from friction.